Okay, let's do one more example of partial derivatives, although we'll be using these throughout the discussion. Let's find partial derivatives of f of x, y, z equals the square root of x squared plus y squared plus z squared. Now, the definition I gave you of partial derivatives only had two variables in it, but as long as I have a multivariable function, I can always find partials. So fx and fz. So fx is going to be the derivative obtained by holding y and z constant. And differentiating with respect to x. So nothing changes in this derivative. What I'm saying is fx is the derivative obtained by holding everything but x constant. And fy, similarly, everything but y is constant. And fz, again, similarly, everything but z is constant. Okay, so let's take a look at this. Fx will be del x of the square root of x squared plus y squared plus z squared. And remember, these are both constant right now. And so really I just have a chain rule problem here in one variable, since x is what I'm differentiating with respect to. And so this is equal to 1/2 times x squared plus y squared plus z squared to the negative 1/2 by the power rule times the derivative of the inside. Remember, y and z are constant, and so the derivative of the inside is just 2x. So after some simplification, you should find the 2 and 1/2 cancel. I get x over the square root of x squared plus y squared plus z squared. Similarly, fy will be del y of the square root of x squared plus y squared plus z squared again. This is now going to be holding x and z constant, and so I'll get 1/2 times x squared plus y squared plus z squared to the negative 1/2 times 2y. And again, that's y over the square root of x squared plus y squared plus z squared. And finally, fz is going to be holding everything but z constant, and I'll get z over the square root of x squared plus y squared plus z squared. Okay, we can take partials of any multivariable function, partial of any function of any number of variables. Fx or f sub xi, for example, will always be hold xi constant, or rather hold xi, differentiating with respect to xi and holding everything besides xi constant. That's how that works.